Welcome. In this video, we're going to go over 63, 64, and 65. Let's squish them all on one video. Here we go. 63, a circuit board is assembled by selecting 4 computer chips at random from a large batch of chips. In this batch, 90% of the chips are acceptable. Let's denote X as the number of acceptable chips out of a sample of 4 from this batch. What's the least probable value of X? So let's break this down. In any given sample, we always have 4, and we know that the probability of being acceptable is 90. So it's kind of like flipping a coin, but the coin's totally different, where it gets 90% of the time it gets one outcome, acceptable, and 10% of the time it gets an outcome unacceptable. So it's kind of like rolling a 10-sided die. 9 sides say acceptable, 1 says unacceptable. That is only 2 outcomes, acceptable, unacceptable. So I'm going to set up a table. Now, knowing the probability of the acceptability, I look at the outcomes. So I know out of a batch of 4, all of them could be acceptable. So that would be 4 acceptable. So they said make X denote the number of acceptable. So I'm going to make a table like this, and I'm going to say 4. That would mean all are acceptable. And again, 3 in any combination would be 3 acceptable, 1 unacceptable. So I'm just kind of making a little note there for you guys. All acceptable, 3 acceptable, 1 unacceptable. And it doesn't really matter which one at this point. It could have been the first, the second, the third, or the fourth that was unacceptable. We just know that 1 of the 3 was unacceptable and 3 were acceptable. And then half of them could be acceptable or only 1 acceptable, or it'd be very rare. But what if you got none acceptable? So that'd be similar to rolling a 10-sided dice 4 times. And each time landing on that unacceptable every single time in a row. So I think logic tells us that the answer is A, because that would be the most shocking. So we know statistically speaking, when someone says what is the least probable, that is the most shocking outcome. Most shocking outcome. But let's go ahead and calculate it. I'll show you how to do that. So these are independent. Each time you roll a dice, that's an independent event, so it can be multiplied. So if they are all good, you had a 90% chance, as long as it's independent, each time you roll. So that'd be 0.9 times 0.9 times 0.9 times 0.9, because the probability of acceptable is 0.9. So that's a pretty big probability. That's 0.6561. So we're not going to put that, because it said what's the least probable. So that would be the most probable. Now kind of doing the same thing here on the other end. If none are acceptable, that would be 0.1 times 0.1 times 0.1 times 0.1, which would mean that you rolled unacceptable 4 times in a row. Really rare. That's 0.0001. Now all these numbers are going to range, numbers less than 1, and again, adding all these up, you would get 1. So they didn't ask, but if you were asked, what's the probability of getting 3 acceptable? That's 0.9 times 0.9 times 0.9 times 0.1. 2 acceptable, 0.9 times 0.9 times 0.1 times 0.1. 1 acceptable, 0.1 times 0.1 times 0.1 times 0.9. Let's do it. Question 64. We're looking at a random sample, and it says the cost of a repair for a large muffler is a mean of $127.95 and a standard deviation of 24. So I'm going to write X bar 127.95, SD 24.03. N is 40. That would mean the degree of freedom would be 40 minus 1, or 39. They want us to kind of get close to a confidence interval of 90. So I can use my tables and all that to find the confidence interval at 90 if I have a degree of freedom of 39, and then go ahead and calculate the confidence interval. But we got fancy calculators for that. So let's do it. I'm going to go to menu, and they want a confidence interval. So don't accidentally click stat test, or you will be very confused. Now, the important part of this question is notice I have X bar and standard deviation. They specifically said that the standard deviation of the question came from the sample. So I'd love to do a Z interval, but I can't. I got to pick T interval. So I picked T interval, bam, and I don't have raw data. I have the actual statistics. So they actually found the mean and the standard deviation, and I feel good because all the stuff on my screen matches the stuff in my problem. So I'm going to put X bar, 12795. S of X, 2403. N, 40. Confidence level, hold on. The confidence level here, the default is 95. So I want to change that to 0.90 and hit OK. Now, what is it? This display may or may not make sense in this question. When I'm looking at this piece of information, X bar is the average plus or minus the margin of error, which is the critical value times the standard deviation of the statistic. So that's the number I need. And that's the number I clue in with my calculator. Notice that this is my statistic, which all look exactly the same. This is my margin of error. With my calculator, I get 6.40, and that's pretty darn close to B. Next question. This is an Algebra 2 question. So hopefully you remember how to do it. If not, let's jog your memory. We get a mean, a standard deviation, and an actual value on the chemistry exam. And then on the calculus, we get a mean, a standard deviation, and an actual value. So we use the formula AP statistics. Take your actual value. So we actually got an 81. And what did you predict to get? Well, the average of the class was 75. So actual minus predicted divided by the standard deviation, and we get a z-score of 0.5. So you did better than the average person on the test, which we know we did because an 81 is better than a 75. Now let's look at the calc exam. The z-score is actual minus predicted over standard deviation, so the actual score I got on that was 84. Notice that looks like it's better, but it all depends on what was the mean and what was the standard deviation. So the standard deviation was 8, plug it all in, and I get the same, which translates to, please take these notes, that translates to exactly the same score, which is why we picked C. Thanks for joining us.